And we have some WAEC question here. The first one says 3m over 2n minus n minus 1 over 5n plus n minus 2 over 10n. Given that n is not equal to 0. So we have to simplify this. How do we do this? Now, the denominators are not the same, so we need to look for LCM of 2n, 5n, and 10n. The LCM is 10n. 10n can divide all of this. 10n divided by 2n is 5. Got it? 10n over 2n, n will cancel, and 10 divided by 2 is 5. You multiply the 5 by this 3m. That will be 15m minus 10n divided by 5m. n will cancel. 10 divided by 5 is 2. Multiply the 2 by the numerator. n minus 1. n plus 10n divided by 10n is 1. 1 times n minus 2 is n minus 2. So this will be now 15m minus 2 times m is 2m. A minus times minus is plus. 2 times 1 is 2. m plus this m minus 2 over 10n. Collecting like terms, all the m, let's bring them together. We'll have 15m minus 2m plus m plus 2 minus 2 over 10n. 2 minus 2 is done. m plus 15m is 16m. Then 16m minus this 2m is 14m. We have 14m over 10n. 2 here is 7. 2 here 5. So our answer is 7m over 5n. X minus 1 all over s squared minus 9. Okay. For this, let me first of all factorize this expression here so that I will have 1 over x minus 3 minus 3 times x minus 1 all over, this is a perfect square, s squared and 9 squared, so I can apply difference of 2 squared there. So I'll have x plus 3 times x minus 3. So now, looking for LCM of this and this, LCM of x minus 3 and this x plus 3 and x minus 3 should be x plus 3 and x minus 3. So that when I divide this by this, x minus 3 will be gone. I'll be left with only x plus 3 multiplied by 1. So I'll have x plus 3 here, and minus x plus 3 times x minus 3 divided by this will be 1. And 1 multiplied by this, I have 3 times x minus 1. So that when I distribute this, I'll have x plus 3 minus 3x, then minus times minus is plus, all over s plus 3 and s minus 3. Let's collect like terms, this and this, and this and this. I have x minus 3x plus 3 plus 3 all over s plus 3 and s minus 3. X minus 3s is minus 2x. Then 3 plus 3 is 6 all over s plus 3 and s minus 3. 2 is common here, so we factor that s plus 3 over s plus 3 times s minus 3. So s plus 3 will be gone. We'll be left with minus 2 over s minus 3. That's our final answer. Question 23. Have 3x plus 2 over 3 minus x minus 1 over 4 minus 5 over 12. Again, we need to look for LCM of this fraction 3, 4, and 12. The LCM is 12 itself. 12 divided by 3 is 4. Multiply the 4 by the numerator. I have 4 times 3s plus 2 minus 12 divided by 4 is 3. Multiply the 3 by the numerator. 3 times s minus 1. Then 12 divided by 12 is 1. Multiplying 1 by 5 is 5. And distributing this 4, we have 4 times 3s is 12s. 4 times 2 is 8. Negative 3 times s is negative 3s. Then negative 3 times negative 1 is positive 3. And minus this 5 all over 12. Collecting like terms, we have 12s minus 3s plus 8 plus this 3 and minus 5 over 12. 12x minus 3s is 9x. 8 plus 3 is 11. 11 minus 5 is 6 over 12. 3 is common to this. So let's factor out 3. 3 into 9 divided 3 is 3. 3s. Then 6 divided 3 is 2 over 12. 3 here 1, 3 here 4. So we have 3x plus 2 over 4. 24, we have 2x over s squared minus y squared plus 1 over y minus x. Let me factorize this using difference of 2 squared. So I have 2x over s plus y and s minus y plus 1 over y minus x. I want to make this y minus x to take this form. As is, instead of having y minus x, I want it to be x minus y. And for me to do that, I will need to multiply this by negative 1. So if I multiply this time by negative 1, my expression becomes 2x over s plus y and s minus y minus 1 over s minus y. The plus changed to minus because I reversed the order of this second expression there. The LCM of this and this is x plus y and x minus y. S plus y times x minus y. And this divided by this will be 1. 1 times 2s is 2s. This divided by this, only this will cancel out. I will have this left. I have minus 1 times s plus y, which is 2x minus s minus y over s plus y and s minus y. 2x minus x is x. I have x minus y over s plus y times x minus y. S minus y divided by x minus y is 1. So my final answer is 1 over x plus y. Question 25. We have 3 over x minus 15 over 2y divided by 6 over x, y. Applying Bodmans, we need to solve the expression in bracket first. And looking for LCM of x and 2y. The LCM of x and 2y is 2xy. 2xy divided by x is 2y. If I take 2xy divide x will cancel. We are left with 2y. So we multiply that 2y by 3. That is 6y. Then 2xy again divided by 2y. Y will cancel and 2 will cancel. We left with x. X times 15 is 15x. That is the expression in brackets. Then divided by 6 over xy. This will be 6y minus 15x over 2xy. When dividing by a fraction, the sign of division will change to multiplication. Then we multiply by the reciprocal of this fraction. So I have x over xy over 6. Sy will cancel sy. So that I have 6y minus 15x over 2 times 6 is 12. Now in this numerator, 3 is common since 3 can divide 6 and 15. So factor it 3 into 2y minus 5x over 12 over 12. 3 here 1, 3 here 4. So our answer is 2y minus 5x over 4. And 26. 26 over 1 minus s squared over s minus s squared. Let's apply difference of 2 squared here. The numerator plus 1 is a perfect square and s squared is also perfect square. So I have 1 plus s and 1 minus s all over. S is common here. I have s into 1 minus s. S into 1 minus s. The 1 minus s will cancel it. So my answer is 1 plus s over s. 7 we have 18s squared minus 8 all over 6s squared minus 11s minus 10. In the numerator, 2 rather is common. So let's factor that out first. 2 here will give me 9s squared and 2 here will give me 4 all over. This is quadratic. So if you factor that, to factorize that, let me do it separately here. 6s squared minus 11x minus 10. We multiply 6s squared by this 10 to give me negative 60s squared. And 2 factors of 60s squared that can add up to negative 11, negative 15x, and 4x. Remember that 15s times 4 is negative 15s times 4s is negative 60s squared. And negative 15s plus 4s is negative 11x. So we will replace these middle terms with the factor so that this expression becomes 6s squared minus 15x plus 4x minus 10. Now if I group this by 2 by 2, I have 6s squared minus 15x then plus 4x minus 10. In this first bracket, 3s is common. I have 3s into 6s squared divided 3s is 2x. Now 15s divided 3s is 5. Plus, in this second bracket, 2 is common. 4s divided by 2 is 2s, and 10 divided by 2 is 5. So I have a common factor 2s minus 5. 2x minus 5 as my common factor, then I group this and this together. 3s plus 2. Now, excuse me, now that I have the numerator in factorized form, I'm going to replace it in my fraction. How? Oh, what was the factors now? 2x minus 5, 2x minus 5, and 3s plus 2. 3s plus 2. Now factorizing the expression up there, we have 2 multiplied by, this is a perfect square, so 9 can be written as 3 squared, then s squared, minus 2 to 4 can be written as 2 squared, then all over 2x minus 5 and 3x plus 2, so that I can apply difference of 2 squared in this numerator. If I do that, I'll have 2 multiplied by 3x plus 2 times 3x minus 2 and all over 2x minus 5 and 3s plus 2. So this 3s plus 2 can cancel this. I will therefore be left with 2 times 3x minus 2 over 2x minus 5 as my final answer. Okay, now we'll move on to the final question here, which is s squared minus y squared all over s squared plus sy. Applying difference of 2 squared to the numerator, I will have x plus y and x minus y all over. In the denominator, s is common, so factor that, I'll have x plus y. S plus y will cancel s plus y, so I'll be left with s minus y over x. My final answer.